Let's be honest, we all think of AI as this software thing, right? Living in the cloud. But what if I told you that behind every single AI algorithm, there's a huge physical world? I'm talking silicon, steel, and a whole lot of raw power. Today, we're going to peel back that software layer and show you the massive industrial engine that truly makes AI work.
So, seriously, when you think of AI, what's the first thing that pops into your head? Is it just lines of code scrolling down a screen? Maybe a chatbot you've talked to? Yeah, for most people, it's pretty abstract, right? Something just out there in the digital ether.
But the reality? Well, it looks a lot more like this. This is the real face of AI. A huge, sprawling, global supply chain of actual physical stuff. And this map, with these 50 key companies, is going to be our guide today. It shows this four-layer industrial stack, and we're going to break down every single one, starting right from the bottom. All right, so our journey begins at the very foundation of it all, the silicon chip. Before any AI can learn a thing or create a single image, its brain, this tiny chip, has to be physically forged. And get this, it all starts with sand. Think about it. Every single image you generate, every question you ask an AI, it all starts as just a little pulse of electricity on an incredibly complex piece of silicon. I mean, without these chips, the whole AI revolution, it's just a cool idea in a science paper. That's it.
So, how do you actually make one of these silicon brains? Well, it's kind of like a three-part symphony. First, you've got the architects, the ones who design the chips. Then you have the builders, the manufacturers. They're called foundries that actually make them. And finally, you have the optics specialists, the people who create these super high-speed connections that let all this hardware talk to each other. And here's the crazy part. This whole process is dominated by just a few absolute titans. You've got the chip designers, like NVIDIA and ARM, drawing up the blueprints. Then you have this one company, ASML, that makes the one-of-a-kind, unbelievably advanced machines you need to even build these things. And then finally, the master builders, the foundries like TSMC. They're the ones who turn those designs into actual silicon. It's this incredible chain where every single link is hyper-specialized. Okay, so you've got this super powerful chip, but a chip on its own is, well, pretty useless. It needs a body to live in. And that brings us to our second layer, assembling these chips into the real workhorses of AI, the servers. Now, building an AI server isn't as simple as just plugging in a chip. No way. It's this incredibly complex machine. You need specialized memory, custom casings, and, this is absolutely crucial, super advanced cooling systems. And then it all has to be put together by manufacturing experts. And for that, you need a whole new crew of specialists. You've got your memory providers for that high-speed RAM. You have companies like Dell building the actual server box, the chassis. Then you have others, like Vertiv, who are totally focused on those critical cooling systems to stop everything from melting. And finally, you have manufacturing giants like Flex, who take all these different pieces and assemble them into a working server. All right, so now we have our AI engines. The servers are built. But what now? Well, we need to connect them. And this is where we zoom way out, from just one rack of servers to the absolutely massive data centers that are the real backbone of the cloud. Yeah, these powerful servers don't just sit in some back room. We're talking tens of thousands of them, all stacked up inside these giant data centers. They're all networked together to basically form one single global supercomputer, and it's all managed by the big cloud providers. And this is where we start to see some names you'll probably recognize. You've got networking companies like Arista that build the digital nervous system for the whole thing. Then you have the hyperscalers. You know who I'm talking about, the giants. Google, Microsoft, Amazon. They run these enormous cloud fleets. But you also have more specialized neo-cloud providers who focus purely on high-performance computing just for AI. So, let's recap. We have the chips, we have the servers, we have the network that connects them all together. But this entire global infrastructure, this massive digital brain, it has this absolutely voracious, constantly growing appetite. But an appetite for what? Just one word: energy. We're talking raw, massive amounts of electrical power. And that is the fourth and final layer of our AI stack. And honestly, it's arguably the most critical one of all. And that brings us to the great unseen engine of this whole AI revolution, the power grid. Simple as that. Without a massive and reliable supply of energy, none of this works, period. So if we look back at our map, we can see the final pieces of this puzzle falling into place. The future of AI is now physically, literally tied to our ability to generate more power. I'm talking everything from traditional sources all the way to next-gen nuclear. And it's also tied to our ability to store that power, to make sure the lights of the AI world, they never ever go out. And so here, we have the literal power players. You've got energy generation companies, including some really interesting emerging nuclear specialists like Oklo, that provide the raw electricity. And then on the other side, you've got energy storage companies like Fluence, who are becoming absolutely vital for keeping the grid stable as AI's demand for power just continues to skyrocket. Okay, so let's just step back for a second and look at the whole picture we've just built. We've traced this entire path, starting from a single grain of sand, all the way to a network that spans the entire globe. What we've seen are the 4 layers of the physical AI stack, and they all depend on each other. It all starts with the silicon brain, which gets assembled into the hardware engine. That engine is then connected through the global network, and the whole thing is fueled, finally, by a massive power source. And there you have it, the whole map. So the next time you use an AI tool, maybe you can picture this incredibly complex global dance of hardware, networking, and energy that's all happening just behind the scenes. Because it really isn't just code, is it? It's a massive physical industry. Which, of course, leaves us with one last really crucial question. As the demand for AI just keeps exploding, which part of this physical map, which one of these boxes, is going to be the next big bottleneck? Are we going to run out of chips? Or maybe data center space? Or when it comes right down to it, will it all be about a shortage of raw energy? Something to think about. Thanks for watching.